All right, so we want to take a look at derivatives of trig functions. Now, to be honest, some of these eventually can get reasonably complicated, but for the most part, maybe just the basic ones you want to have committed to memory for tests or something. If we ask a more complicated one, I would put a hint in there. I don't expect you to know all of them off the top of your head, but the ones that are probably good to know because they get used so commonly are the derivatives of sine and cosine. So sine, the derivative is cosine, and cosine, the derivative is negative sine. We'll do some exploration sometimes in class, but it's kind of interesting to see, that one is the slope of the other one. A couple other commonly used ones are the derivative of tangent, is secant squared x. And the derivative of secant is secant x times tangent x. I don't know how often we'll use the other ones. The rest of them, cotangent is negative cosecant, cosecant is negative cosecant times cotangent. So once again, probably after sine and cosine, you could start to look them up if you needed to. All right, so let's try some examples of these. And they'll almost always combine them with other rules. Otherwise, on their own, they're pretty easy, right? Just you can go through the proof of it, but derivative of sine is cosine. So if you know that, that would be done. So we'll do some that have a little bit more going on here. All right, let's try. A function that's going to need quotient rule. All right, so we have our high and our low, right? The top and the bottom, and it happens to have a trig function in it, but just like normal, we should write down f and g or high and low. So the top of this is cosine of x. The d high, or the derivative of the top, derivative of cosine is negative sine of x. And then low is the bottom, 4x squared. The derivative of the bottom, or d low, is 8x. So now we at least have all our parts for quotient rule. And so quotient rule, low d high minus high d low over the denominator square we go. So low d high, this one times this one. So 4x squared times negative sine, so maybe I'll put the negative out front, just looks a little better. Negative 4x squared times sine of x. And then minus 8x times cosine, so minus 8x cosine of x. All right, so low d high minus high d low. And then over the denominator squared, be careful, it's 4x squared. So that means the 4 and the x squared, so 16x to the 4th. The denominator times itself. And then essentially we're done. If it was the derivative mastery test or even on homework, they should mark this correct, you're fine. If you notice some really easy simplifying you can do, some low-hanging fruit here, go for it. Everything here is divisible by 4, right? There's 2 terms on the top and 1 term on the bottom. So if you want to, you could simplify to negative x squared sine of x minus 2x cosine of x all over 4 x to the 4th. And then you might also notice all of these have at least one extra x in them. Just to not do too much stuff at once, we could have done it back here. Maybe I'll point it out back here and we'll simplify it after that. So there's at least an x in this term. There's 4 of them here, right? So that'll leave you with 3, and there's 2 of them there. So if I go ahead and cancel this one, will leave me with 3 on the bottom, right? Cancel an x out of every term, and a single x here. So once again, you don't have to go crazy on simplifying. The goal is really to take the derivative, and there's the derivative, simplified or not. All right, let's try one maybe that has product rule and maybe more than one trig function. Right, a lot of times those multiplication dots aren't there, but sometimes I like to emphasize them for myself. That way I don't, especially when it's not a very big product rule, but it's still a product rule because it's a function times a function, that I don't let those product rule ones kind of slip by without noticing them. All right, so if we want the derivative of this, the first term is just 1. We can kind of look it up from our known values. So the derivative of cosecant is negative cosecant times cotangent. Derivative of this is this. And then the other one we have to use product rule, so still probably a good idea to write down our choices for f and g. So f is x, which means the derivative of f is 1, right? Just derivative of 1x is 1. And g is tangent of x, and the derivative of tangent is secant squared. And so now we're ready with our pieces of product rule. So first times derivative of the second. So x times secant of x, or secant squared. And then plus the other two multiply together, so tangent of x times 1. And there's not really very much, if any, simplifying you can do there. I don't think there's any. So cosecant times cotangent. I'm just trying to make it fit all on one line. X times secant squared plus tangent of x. So first one was just a single term. Second one used product rule. There's the derivative of the original function.